Hello, this is Mrs. Peck showing you how to fill in page 8 of your notes of Unit 11. On the last page, we saw how we can come up with a proper name for a chemical, for an organic chemical compound based on the structural formula. Now we're going the other way around, and you will see that that's somewhat easier to do. So if we start with the first example, our main chain is given as a butane. So that means we know we have 4 carbons. Then we have a special feature named, and that is an amine. So when you look into your reference table R, where you have all the functional groups, you will find that an amine group is an N with 2 other things attached to it. The number 2 in the beginning of the name tells you that that amine is attached to the second carbon. And you can start counting the carbons from either direction, but you can just as well just start from the left side in, because you are deciding where to put it. It just needs to be from the second carbon from the outside in. So we have a nitrogen here that has 2 other things attached, and to be precise, unless it tells you anything different, and you're not going to have that case, it will be 2 hydrogens that are attached to this carbon, so it's NH2. And that takes care of everything in the name, so the rest is hydrogens until every carbon has 4 bonds. Don't forget to add those hydrogens in the end, because otherwise you don't have a complete molecule. Good. And that's really all there is to it. Let's do one more. You have 2-methyl-2-propanol. Main chain's name is propane, 3 carbons. Again, you have 2 special features on that. You have on carbon number 2 the ending OL, so there's an alcoholic group, an OH, on there. And then you have a 2-methyl. So on that same second carbon, we also have a methyl group, which is the C with the corresponding number of hydrogens, so CH3. That means the middle carbon already has 4 bonds, and therefore doesn't get any hydrogens anymore, and the other 2 carbons have their respective number of hydrogens to fill up the remaining bonds. Okay, tripentanoic acid and the 3-bromo-2-methylhexane on your own. Pause the video at this point. So here you see what they should be looking like. The pentanoic acid must have 5 carbons in a row, and because its name ends in oic acid, it is an organic acid, so on that last carbon you must have or on the first carbon, you must have that acid group with a double bonded O and a single bonded OH. And the 3-bromo-2-methylhexane, hexane tells you have 6 carbons in a row. The 3-bromo says that on the third carbon from the side in is a bromine attached. Well, I guess the hydrogen then. And that bromine could be either up or down, it really doesn't matter. And the same for the CH3 group that is indicated by the 2-methyl, that could be up or down, but it must be on the second carbon from the outside in. Okay, let's have a look at that challenge. It says 2-amino-propanoic acid, which is the proper IUPAC name for the amino acid alanine. So propanoic tells us it has 3 carbons in a row. Then it has hydroxyphosphoric acid, so it has that acid combination, the double bonded O and the single bonded H on it. But then it also has a 2-amino, so on the second you have an amine with